make an estimate.
Hey, good evening, everyone. Good evening, everyone.
Good evening.
There you go. Hi, my name is Ravi Mikkelsen. I am the founder and organizer of ClimateLink. So we are a meetup group and also a company that's mission is to accelerate capital deployment to fight climate change. And tonight we have a very exciting topic on electric aviation. It's one of the main things we need to do to fight climate change is electrify everything. And aviation is seen as one of the hardest problems to tackle. So this will be really interesting. And we've got Elroy Air and Joby Aviation. And we'll hear from our host at Orange, Silicon Valley shortly. So first we've networked and we've ate, do some quick introductions and announcements, and then we'll get to the main topic, all the talks, and then we'll have a chance for more networking and food and drinks afterwards, and then they'll kick us out. If you would like to receive the link to the video and slides, if the speakers will share them, you can go to that link right there and give me your email address, and you'll get a one-time email, that's it. If not, no worries, you won't get the stuff. And yeah, so if you haven't been to the bathroom yet, they're out by the elevators to our left. The Wi-Fi is OSV events. George, do you have the password?
Orange SF.
Orange SF. Okay, pretty easy. So let's see. I'll do. So like I said, the mission of ClimateLink is to accelerate capital deployment to fight climate change, and specifically our mission is to help deploy $1 trillion per year, which is still a faraway goal. So we do that on several fronts, primarily by helping to matchmake capital seekers with capital providers. And one big thing that we're working on right now that the Bay Area does not have is a centralized clean tech incubator. So we're looking at a space in West Oakland right now, actually a few spaces. But one thing that's really interesting about this area is that it's in an opportunity zone. And so just by the fact of being there, all startups that come through will be more economically attractive because investors will be able to defer and also have some forgiven capital gains taxes, so they can shift that off. But there'll be wet labs for chemistry, biotech, ag, materials, electronics. There'll be rooftop testing for solar, big open space. If any of if Joby or Elroy want to move over to West Oakland, yeah, so there'll be space for everything, including events. So if you're looking for space, please let me know. I'm taking pre-commits for our first office area. One big thing that we're trying to do is create a network map of the global clean tech ecosystem so that we can better matchmake. So who are the customers, who are the capital providers, who are the capital seekers, the government agencies, that we can create these nodal relationships so that we can help companies from inspiration all the way to IPO, from Eureka to exit, from cradle to cradle. So we need to move a lot faster than we are. And so this is what we think about every day. There's lots of different ways you can connect with us. They're all right there. I won't read it for you. We've got jobs. Is anyone hiring and they'd like to announce their jobs? No jobs. Okay. There's nobody hiring here. Bad jobs market. Is Elroy or Joby hiring?
Joby is hired.
Great. As is Elroy.
Yeah, we, long conversation, but yeah, looking to bring on hires in the summer.
Great. So you can announce that during your talks too. All right. Is anyone looking for a job? Also no. We've reached, this is the first meetup where we've reached full employment. All right. Congrats. Okay, with that, I'm going to turn it over to George Livingston, who will tell you all a little bit about Orange.
Thanks, Robbie.
So welcome everyone. This event was co-organized with Will Barkus. His son's sick, so he couldn't make it tonight. But I'll just tell you a little bit about Orange. So Orange is a massive multinational corporation. We have about 260 million customers in 28 countries around the world, and enterprise services in about 220 countries. We're not just a telco, so we're a multi-service operator. We're a bank, actually, in France. We do mobile money transfers in Africa. We provide cybersecurity services. And then we also are actually an energy player, so we sell energy in some power and electricity in some markets in Europe. We're an off-grid solar provider in Africa. And we also sell home IoT devices to help manage home electricity use. So that's Orange, basically. We are also users of a lot of electricity around the world, and so we're concerned about our carbon footprint as well. Just to say a little about commercial aviation, I went to a talk a few weeks ago from United, and their chief sustainability officer, and he spoke about how their strategy is basically to switch over to clean jet fuel or renewable jet fuel. And that seems like a very tough route to take. So about 2% of global emissions comes from commercial aviation, and right now about 0.1% of jet fuel is renewable. So to switch over that entire fuel supply is difficult. But I was really excited to learn about the two startups that are going to speak tonight, because they're kind of taking a different approach and saying, well, if you move away from commercial aviation and look at shorter distance flights and look at cities, you can actually do a lot more quickly in the aviation sector. So with that, I'll turn it over to the startups, and if you all have any questions about Orange after the talk, feel free to come and speak with me. I'm happy to tell you more about what we do. Thank you.
Thanks again, George and Orange. And by process of alphabetical order, Clint with Elroy, you are first.
How's everybody doing?
Great. How are you?
Really good. Okay, well, found out during a walk with my wife today that some folks that were at our offices this morning are going to get some of the same content twice, so apologies in advance. But anyway, excellent. So I'm Clint Cope. I'm VP of Engineering at Elroy Air. We are a aerospace and logistics startup located just over in the Dogpatch. And I was surprised that it was probably going to be actually a shorter walk in terms of time to get here today. I did not expect that it was going to take nearly 45 minutes to park my car. So I will take that into account next time. Anyway, we're going to start things off with a video about our company.
Flexible delivery of goods is forcing logistics to adapt. The need for airport infrastructure prevents cargo aircraft from delivering directly to the customer. In addition, just-in-time logistics is hampered by traffic jams and poor road conditions. We have a vision for the future where cargo can be delivered rapidly to any location, near or far. Recent advances in electric powertrain, machine perception, and autonomous flight enable new possibilities for logistics. Elroy Air is developing an autonomous vertical takeoff and landing aircraft transporting 200 to 500 pounds of cargo over a 300-mile range by air. Elroy Air is a small team of experts in aerospace, UAVs, industrial design, supply chain, and robotics. We have designed a complete aircraft and cargo solution and have already built working prototypes of our cargo handling, ground navigation systems, and subscale aircraft. Elroy Air's system brings new flexibility to express logistics, enabling rapid aerial delivery of cargo to businesses worldwide.
Okay. So this is the vision. Our aircraft reduces the links in supply chain so that a single vehicle can carry cargo directly from a commercial customer to everything from a distribution center to a job site to you name it. But we're making it so that instead of having multiple links along the way, we have an aircraft that can carry 300 pounds of cargo that can deliver, to a field, to a parking lot, to an oil rig. Those are just the type of applications we're looking at. This thing is designed more or less like the F-150 of the skies. It's a rough and tumble aircraft that's designed to be abused. And so we're really trying to design this more like a workhorse aircraft rather than something that is like a specialized and precious asset. Here's a system overview. We use 6 rotors for takeoff and landing. That gives the system redundancy. It gives us a far higher factor of safety than what you'd see from a helicopter, for example. We use an internal combustion engine generator. And so I'll get into a little bit later why we picked a hybrid electric system versus going pure electric on this first aircraft. But the most basic answer I can give you right now is range versus customer demand. There's detect and avoid systems built into this vehicle as well. We're looking at these systems as something where eventually you may have one ground-based pilot who is more or less babysitting 20 systems simultaneously. So we're looking at this as something that is highly beneficial to commercial aviation because right now we're seeing pilot shortages. But also that lots of really poor decision making gets made within logistics, namely just picking the biggest aircraft for the application and wasting huge amounts of fuel in the process. So yeah, I'll jump right into why we picked hybrid propulsion. Based on the current aircraft design, we have only about 50 kilometers of range if we go with a pure electric system. And that's just purely driven by like available at scale battery development. Like we don't want to get into the battery business as a company, and so also for better or worse, we are doing things under venture timeframes. And so waiting for that perfect battery is just really something that we can't do and still build a business. That being said, as battery safety, energy and power density increase, the interior of our aircraft is built like, I think, the aerospace equivalent of a server rack. So we can do things like pull out fuel tanks, remove engines, and replace that with a motor pylon for an electric motor so that we don't have this asset that ends up getting tossed as technology improves. So our general approach as a company is to look for best-of-breed technologies, partner them with the custom airframe and robotics tech that we've developed for the on-the-ground portion of the mission, and then make that aircraft really easy to continuously improve. That being said, every one of those continuous improvements would represent supplemental type certification from the FAA, but it's one of those things that as an early company that's getting into this space, like we've kind of just resolved ourselves that this is how things are going to be as the tech evolves. So here's a typical mission with our system. Vertical takeoff and landing aircraft, the electric motors on board, and at this point the aircraft backs away to either be unloaded by ground personnel and then reloaded. or it taxis over and picks up another pod and takes off again. So we've taken great strides to make the system as flexible as possible for people who are doing like really high throughput logistics that would be like just cranking cargo pods through their space on a continuous basis, and customers that are really only using the system occasionally. Trying to keep as small of a footprint as possible because we know that eventually we will be landing these aircraft, closer to urban surroundings, and so these are two prime examples. The example on the left is like the center circle of a helipad. We don't have to use the entire that entire surface. We're much smaller than like a Robinson R44 or for example like a Bell 406, 407. That gives us great flexibility to do things like in the next example to, like I said, land in the customer's parking lot. So we can imagine probably it's more of like a 5 years out in rural environments type of first test, but to be able to fence off a section of a customer's parking lot and land directly at their site. As I talked about quite a bit, robotic loading and unloading are a big way that we see to increase the efficiency and throughput of the system. So I've got a quick video to show you guys how our aircraft will grab cargo pods and lift them up to the belly of the aircraft and latch them autonomously. So this was one of the robots that we built in the earliest days of the company. This was something that we knew we needed to understand end to end. And so the vehicle itself is representational of the landing gear and the tail gear. And this vehicle was also used for some of our first studies with like how we were going to be implementing autonomy on the vehicle. So we're using LiDAR for most of the ground-based portions of the system, including landing zone detection, and then using radar for the in-flight detection. We wanted the grasping and latching system to be as imprecise as possible, so even if the vehicle hasn't perfectly taxied over the top of the pod, it can still lift cargo to its belly. And that last slide, that last image, that cargo pod is now fully integrated into the vehicle. There's 4 shear pins that link that to the bottom of the fuselage, and so from a safety perspective, it's great. It makes it much easier to explain our safety case to the FAA because we now have this decoupled payload to the vehicle. But it's also great because we now have a system that we could also do at high volume and low cost. So the example you saw up there, it's something that we did out of composites just because on the first vehicles we were trying to keep everything as light as humanly possible. As the overall weight of our production aircraft comes down, which is we are in the fortunate state that it'll do that because we ended up taking a heavier approach toward that in the interest of building quickly. We're imagining doing the cargo pods essentially as a roto-molded plastic that would enable us to then recycle those pods at the end of their life. So they'd have an internal aluminum frame, and then we'd be using a polyethylene exterior on those. So we think of that, the cargo pods as something that we need to pay a lot of attention toward because we're going to have far more of those than we're going to have aircraft. The ratio of cargo pods to aircraft could be as high as 20 to 1. And so thinking about the whole supply chain surrounding that is important because they will be one of those things that's used and abused.
Do you want to save questions for the end or take them throughout?
Yeah, go.
Okay. So you said that basically the alignment and lifting system can be very imprecise. How far off sort of true can it be?
20 degrees in any plane. So yeah, it's like, that was one of the great things about that grasper, because like we found that we could just use the leashes to give a lot of flexibility there. So but we're looking at, using robotics as a tool to handle like the entire logistics process. So we really are trying to work within a mode that we realize that, things with 8-foot rotors are pretty dangerous, and so like creating some separation between the human and the aircraft is important. So we're behaving within a model, like, and I probably said this already, but it's similar to Kiva Robotics, where you have the robots operating in the thick of things, and then you have the operators coming toward those, and so you have this interesting kind of assistant type relationship that starts happening between these two. It's also good because we expect with these vehicles that they're going to be moving pretty darn rapidly by the time we get to scale, and so when we can start setting up some of those relationships early, it makes it easier for us to do everything from site planning to also the training that we need to think about ahead of time when we're thinking about this kind of new relationship to an aircraft. We're also looking at the pods themselves as something that makes the aircraft highly extensible. And so, an interesting application and why I have the ISR pod up here is because we're working with a partner in South Africa that does anti-poaching operations. And so they're actually using what were formerly military UAVs for those applications. So that gives them the ability to use a common platform and then serve a lot of roles there. And then, yeah.
Can you say out the acronyms?
Oh yeah, sure. The ISR is essentially it's camera-based surveillance. Medevac and CASEVAC. Medevac, you're trying to rescue a person who's still alive. CASEVAC, you may be removing a body from the scene. And then I guess the last example that's up there is we're looking at disaster relief applications where we can do things like leave behind a generator. We actually scaled the vehicle due to some of the conversations that we've had with USAID to make sure that we can fit the tents, everything from tents to tools to the big rolls of plastic that they use when they're setting up temporary encampments after an event. And so on the customer research side, we've gone pretty broad here to make sure that we're serving the needs of a lot of different markets while at the same time not creating a total design by committee vehicle that's not useful to anybody. The cargo pods themselves are designed to stack on top of each other, so you can look at them as each one of these was preloaded. They could be preloaded into a container, and then once they reach port, could be shipped off to their individual destination points. The latches on the pods can actually nest within the feet, and so you can stack them and completely fill a 20-foot ISO container. So let's see if these actually pop up.
Question, do the cargo pods have rollers on the bottom so you can push?
They do. There's two wheels at the back of the rollers, or the two wheels at the back of the pod, and you can grab the tow handle on the front of them. I feel really bad because like the stuff I'm showing you guys is the previous gen stuff tonight. All of the really cool things, as Julie will attest, are sitting in the shop right now. We're in this stage of just like planning and doing all the fun clawing and scratching that it takes when you're trying to get like venture capital to really back the idea of building an airplane. And now that all the parts are arriving, it is just all feeling like amazingly real, because it all looks a heck of a lot smaller in CAD. And then when it starts like actually taking up floor space, and you now have to like have people think about how the heck am I going to move this thing, or wow, that looks really big, but it's amazingly light. It's a kind of special, super magical time at the company right now. Yeah, go ahead.
You mentioned that the pods are stackable. Are they stackable in flight as well? So if you wanted to drop off one on the way to another destination?
Yeah, that's a great question. What we did instead was we designed a divider system into the pods, and then also designed the aircraft in such a way where we can have as much of like a 2 foot in either direction center of gravity shift. So people will basically pull their portion of the cargo out of the pod from their subdivided section, and then the aircraft taxis back over and picks up the pod again. We've had to be really sensitive in terms of weight and aerodynamics in terms of stacking the pods and doing anything that's really much bigger than the pods beneath the aircraft if we do a special application. But yeah, the next gen vehicle would be the type of thing where we start doing something very similar to that. I'm just going to open all of these. This pretty much covers most of the stuff that I've been going through with you guys tonight. I guess one of the topics that I didn't really get into was that electric aviation is making life interesting because you now have like new vehicles where you're trying to explain to the FAA that you really would like to do that you can get away with doing things like on inspection. And on inspection means instead of doing lots of potentially unnecessary preventative maintenance on the aircraft, you now have the ability to say to the FAA, I have a motor that is good for 10,000 flight hours, and I only use it for the and my system is hyper redundant, and so even if I would lose one of those motors, the chance of having some type of event that could cause danger to life and limb is exceedingly low. So it's going to be interesting as more companies enter the fray, like how exactly that ends up getting resolved. But the electric motors are a huge reason why our aircraft is extremely safe. But it's also going to offer huge benefits to those who are operating them, because you can start looking at the maintenance schedules similar to what you'd see in like a truck or an automobile, and much less so the type of very hyper regular and hyper precise maintenance plans that you see in most of general aviation today.
Question. So is there one motor per blade mount?
Yeah, there is. There's 6 individual motors, and then like really the equivalent of a 7th motor on there, but we're using that motor as a generator.
Okay. And then you said that you have 6 blades for lift as a redundancy.
Mm-hmm.
How many do you actually need for lift with a pod?
Great question. So technically speaking, the aircraft can get off the ground with 5 rotors. The aircraft can lose any single rotor at the corners, and we can land the aircraft as like a typical mission. If we lose the center rotors for any reason, we can actually do a controlled descent with the vehicle. And then the last option that we have, which is probably going to end up being the FAA's preferred option, is to do, if we ever have like a full lift system failure, we land the aircraft like a conventional aircraft. Things like full aircraft parachutes and stuff like that were really poo-pooed very early, because they said, imagine playing pinball with skyscrapers. So we're not going to be doing that.
So you said you're like 5 years away from having an aircraft like this land in like a company parking lot.
Yeah.
Is that just from a regulatory perspective? Like what sort of hurdles do you see as far as?
It's completely regulatory. It's completely regulatory. And let me also heavily caveat that we're 5 years from landing an aircraft in a parking lot in the United States. I think a lot of companies are discovering that moving on to markets outside of the US is really going to be their fastest path to getting the flight hours they need. All right, I'm just going to take you guys through. Oh, Jack, go ahead.
Would there be any exceptions to the rule of being remote from airports? Might there be cases in the future where they actually do have a deployment at the airport?
So I'm going to try to read the question back to you. So you're saying, would there be cases where we're going direct from airport to airport?
No, not necessarily, but there might be a case where the best option would be to do a transition at a local, smaller airport, package or whatever.
I mean, you mean just like the vehicle transitioning from a smaller airport, or?
Yeah, to a smaller airport or both.
Yeah, I mean, I think we've got a lot of, I might not be answering your question correctly, but I'm going to try to stab at it. You can tell me if I'm off base. Yeah, so oh, you're saying like to basically take off from a small airport? Like a conventional aircraft?
Well, not necessarily, but just the fact that if you would have access to it, or it would have a reason to be an exception to the general rule, you would end up landing or...
Oh, yeah, definitely. So we have to look at that. We have to look at that model largely because, like, we need to get heavily. We're going to have to get heavily entrenched within local airport infrastructure as a company. It's like from the very beginning. That's really where we see first operations happening. And so, like, being thoroughly enmeshed in that is actually to the company's advantage because it helps us figure out how to navigate all those wonderful rules and regulations around flying in and out of an airport. It's also important because like we have interest from big logistics companies that that's their bread and butter and they're operating out of there. The big advantages that we start seeing though is that we may be doing things like where we're operating out of an airport or we're flying like directly from a commercial business to an airport. But that we can do things like improve the way that these companies currently do their sort so that we can kind of use smaller airplanes to make it so that they're not doing these long, inefficient routes from all the way across the country. But anyway, spun your question out a little bit there, but hopefully that answered part of it. Okay, cool. So I'm just going to show you guys some videos that I think are cool. They are stuff that we did in the early days of the company. This first one is an aircraft we built called the Aluminum Falcon, and we, no copyright infringement, but anyway, that vehicle enabled us to test sound levels on the vehicle, basically noise pressure dB, and proved out that we could indeed build a vehicle at our size and still have it be under 70 dB. So I have no idea how loud these speakers are up, but we're going to find out soon. So that's just a fun way of saying ambient that day was around 65 and that we really only nudged the needle by 3 dB. Other things that we did in the really early days of the company was just to check that our aerodynamic work made sense. And so that we do a lot of modeling internally. A lot of CFD software. We're using software that the rotorcraft industry is using, has used really heavily, but is being really used more heavily right now within VTOL called Charm, and that enables you to see what the wake of the rotors actually do over the top of wings. But still, that generally doesn't mean anything until you actually go and build the thing, because there's always holes in analysis software that is showing some result that doesn't necessarily represent reality. So we opted to build a 1/5 scale size vehicle, and this is one of the flight tests that we did down on the Central Coast. We had to have the aircraft pretty close to stall for all of these flights because we kept outrunning the drone. This particular aircraft can do about 70 miles an hour, so that M600 that was chasing it was having a really hard time keeping up.
Where was this flight test?
We have access to essentially a testing area right outside Paso Robles. Cool. Almost done, I promise. So here's a quick shot of our shop. Again, I can't show the really fun things, but I can talk about a couple of things that are in this picture. In the bottom portion of the image, that is going to be the replacement for the carbon crawler vehicle that I showed you guys a while ago. It also gives you an idea of how we ended up doing the trusses and the structure for the first demonstrator aircraft. Instead of going full composite, we actually went old school with a steel frame and just put aero skins around that stuff. The other vehicle that you see is our Ironbird. So this is a full-scale, much bigger, much heavier than life, than real-life vehicle that we built to just test out powertrain. This is going to give us the ability to do things like shake our avionics really vigorously and make sure that we're not having any control issues. It's also really important because when you're dealing with high power systems, you can have everything from noise from the motors to just current and just energy doing lots of interesting things when you remove throttle from the aircraft. So this is one of those items that you really have to build when you're building a vehicle this large to make sure that your first flight tests are going to go off with minimal hitches. This is our team. There's 2 people missing from this photo, but we are 16 folks as of today. We've been at this right now for 2 years and a quarter, and I've been just really excited about how fast we've been able to move with such a small team. We couldn't have done any of this stuff without, of course, those that invested in us, but also like the partners that we brought on board. So, as you guys may know, myself and my co-founder were ex-3DR people. We also have a lot of ex-Airware people on the team, and so the company really is a lot like just getting the band back together. These are people that I've worked with for years and trust, and so there really was not a lot of ramping people up to try to figure out if they could do it. We just knew they could do it. So yeah, thanks everybody. I appreciate having us out today, and yeah, happy to field any questions, and yeah, thanks very much.
What did the FAA say about additional air traffic and routing and that kind of thing?
Yeah, so we'll initially start with a model where from the best I can tell, and be piloted. And so there will be a pilot in command. He might not necessarily be on the sticks the whole time, but you're going to have one pilot that's dedicated to a single aircraft. And so he'll be communicating with air traffic control directly via voice comms. The kind of next level up from that is getting these systems to integrate well with TCAS, which is pretty much the FAA's like aircraft-based and ground-based avoidance systems to make sure that you're keeping aircraft out of traffic with each other. We also have to supplement that with having onboard radar systems so that if anything that within those systems gets missed, that our pilot is able to take action. And then, of course, our aircraft will have to have the latest kind of mandated awareness technologies on board, like things like ADS-B, to make sure that one aircraft can sense another aircraft coming. And so beacons will be in very heavy use on this. And that kind of describes the early days, but the way that we see it breaking out, and really the way that NASA and the FAA also see this breaking out, is that in a very short time that's going to be far too heavy a burden to just lump onto air traffic control's already very full plate. And so the idea of autonomous air traffic management systems is something that is starting to see, is starting to see much more press these days, especially because NASA's sunk a bunch of money into it. And then also providers like AirMap, who are doing things like providing your initial paperwork and providing your documentation for your strategy as to how you're going to deconflict. And so they're playing a pretty heavy role in both the type of work that we're doing and also the work that is happening within urban air mobility. And so yeah, eventually I think a lot of the flights that you're going to see over cities are all going to be handled by the robots themselves, which it's both kind of simultaneously scary and exciting. Yeah.
How does your system accommodate intermodal freight ecology? Your ecology. How does your ecology accommodate intermodal freight systems?
Yeah. So I mean, I showed one example with the container. I think like one thing we're doing is kind of is looking at within intermodal freight. What are the parts of our system that work and what are the parts of our system that don't? And so like one really good example is, we're doing internal investigations right now to get the cargo pod from being less of a pod to being more of a cube, where you're just kind of snapping fairings on either side of it so that you don't have a bunch of essentially dead air inside of a shipping container. That's been pretty direct feedback from those that do a lot of shipping and just look at that as like a lot of losses because of that form factor.
I didn't know if maybe you were thinking in terms of just decanting the existing containers, and then loading it somehow, automating the loading, decanting into your more aerodynamic modules.
Right.
You answered that.
Exactly. Yeah, and I think we really have to make that move as a company, largely because the pods themselves, they're going to stack well and they're going to be really great as initial proof of concept work for the company. But yeah, fully optimizing that is a must-have on our roadmap.
Have you started to think about integrating with like freight car tech companies like Uber Freight or like Flexport or anything like that to manage the
yeah, it's funny that you mentioned Uber Freight. So our head of sales is from Uber Freight, and so really a lot of the modeling that we're doing right now has some unsurprisingly uncanny similarities to that, and so the ability to kind of leave the pod anywhere and to have people pre-pack it at their leisure is similar to some of the stuff that we're seeing out of that group. So yeah, and then in terms of the coordination side, yeah, I think it's going to be interesting to see just the sheer amount of work, and maybe not Uber Freight proper, but the work that Uber is putting into like really looking at how the infrastructure side of this is all going to shake out. One of our investors is actually really heavily invested in working with partners to make sure that there's that developers are taking into account things like eVTOL. And that's everything from making sure that there's adequate charging facilities to you name it. But that being said, when you look at the regulatory path for these vehicles that the FAA has never seen before, it could be exceedingly long by the time they get to scale. And so we're looking really heavily there around how we may be able to take advantage of some of those assets earlier than air taxi might be, and start adding some early profitability chains to really what's going to be a big bet for real estate right now. So yeah, it's but anyway, yeah, we're excited about that.
One more question.
One more question. Yeah.
For later designs, do you guys have any plans or have you done any math on mounting lighter solar panels on top of the wings and top of the fuselage to increase the light?
Yeah, so we've liked a lot of the work that Buy Aerospace has done on that type of stuff. It's something that I think ends up being a longer term win once we can get the aircraft to a full electric state. And I also think it's would be one of those things that would be more beneficial toward like almost giving us additional redundancy if we'd ever have an avionics issue. But due to the super high energy and power density requirements that we're seeing, yes, solar would really be a challenge to offer like a huge benefit to this particular design.
Great. Well, thank you so much, Clint.